Okay, good day everyone. I'm here to continue my previous presentation for the voltage drop. In the previous presentation, we discussed the theoretical theory behind voltage drop as well as the codes that govern the voltage drop at kung ano-ano pa yung mga causes and effect ng voltage drop sa ating sistema. So in this video or in this presentation, kakaroon naman tayo ng manual calculation. We will use two approaches. This is the NEC approach and then the PEC approach. So maybe we can start. Okay, for the voltage drop calculation using the PEC approach, this is the formula for the voltage drop. VD is equal to K multiplied by the distance multiplied by the I or the current multiplied by the square root of R squared plus X squared, wherein VD is the voltage drop, R is the line resistance in ohms, which we can obtain from the PEC table 10.1.1.9, as well as the X or the line reactance in 60 Hz in ohms. And then the distance of the device from the source in meters. And for the K, the constant 2 for the single phase and 1.732 for the three phase or square root of 3. Okay, so this is the table 10.1.1.9 AC resistance and reactance, which is based on PEC 2017 page 942 if you will check the PEC. Okay, and then as you can see with the table, there are some values based on the area, then the reactance, as well as the resistance. Okay, let's have some sample problem. Okay, a 15 horsepower motor is to be installed in a 230 volt 3-phase AC system. If the motor is located at 300 feet from the source, calculate its voltage drop. Okay, as we analyze, meron tayong isang motor. Okay, medyo mababa yung voltage, 230 volt na 3-phase, and then located siya 300 feet. Pero if you will observe yung formula natin from Philippine Electrical Code, ang nakalagay doon na D is in meters. Technically, we will convert this 300 feet into meter para mag-fit siya dun sa formula natin. Okay. But before that, kailangan ma-obtain muna natin or makuha natin yung current draw ng motor. Meron tatlong way para makuha yan. Okay, number one, pwedeng kunin natin sa NEC o PEC yung mga value. Then, conventional calculation, yun yung ginagamit natin pagka wala talaga mga available na data. And then yung pinakamadali, pangatlo, yung nameplate rating. Sa nameplate kasi kompleto na nandun na lahat. Yung current rating, kung ano yung power rating niya, ilang HP, and as well as yung mga efficiency tsaka power factor niya. But then, for the sake of the discussion, let's use the conventional calculation. Okay. Calculating voltage drop problem number 1, PEC approach. Okay, for the formula, we will still follow KDI multiplied by the square root of R squared plus X squared. And by the way, square root of R squared plus X squared is the impedance. Okay, going back. For the sake of discussion, we will use a conventional method. And then we will assume that the power factor and the efficiency of the motor to be 80% para mas mabilis ang calculation natin. Okay. And then, as we can see, for us to get the current or the full load amperes of the motor, we multiply 15 horsepower multiplied by 746 for us to convert it in watts. And then the result will be divided to 1.732 multiplied by 230 volts, our system voltage, multiplied by the power factor and the efficiency, which results to 43.89 amperes. Ito na yung full load current ng ating 15 horsepower motor. But then, si PEC, for the calculation of our motors FLA, yung conductor natin, minumultiply natin siya sa 125%. So, multiply natin by 1.25, the result will be 54.86. Etong current na to, ito na yung magiging basis natin for our voltage drop calculation. And then, we will check with the Philippine Electrical Code, Table 3.10.2.6, B16, Table of Conductor Ampacities. Ano ang conductor na pwede niyang gamitin? Based on it, we can use number 6 AWG or 14 mm squared at 90 degrees Celsius. And then, for us to obtain the value of R and X, kukunin natin to sa table 10.1.1.9 na binanggit na pinakita ko kanina. And ito na nakuha natin doon. We will use 0.051 and 0.49 for X and R respectively, assuming PVC yung wrapping ins na ginamit niya. Okay, so using the formula, DD is equal to, since this is a 3-phase, the K will be 1.732. And then, multiplied by the distance, since this is 300 feet, we will need to convert it into meter. That's why we divide it by 3.28. All over, divide natin sa 305. Sir, saan galing yung 305? Based on the table, yung given na value ng X and R based sa PEC is per 305 meters. So, technically, we need it to divide by 305 para mag-fit siya dun sa value nito mga to. And then, multiply by 54.86 which is the calculated full load current natin kanina. Then, the result will be BD is 14.03. 1.732 multiplied by 300 feet or 3.28 or 305 multiplied by 54.86. Let's check yung calculation. Plus 0.051 squared. And there you have it, 14.03. 14.03 volts. It follows that the percent voltage, since nakuha natin, divide natin sa 230, ito na yung system voltage niya. So, lumalabas 6.10% siya, which is based on the Philippine Electrical Code and as well as to sa mga binanggit nating discussion nung nakaraang video tutorial natin. Ang nire-recommend lang nila ay 3 to 5% voltage drop. Consists of, dapat summarize na siya ng branch tsaka ng feeder. Eh dito sa ating problem, dapat at least nasa 3% lang ang makukuha natin. Technically, 14 mm squared conductor is not recommended. Because of that, we need to recalculate and check for another cable which will result to an acceptable voltage drop. Okay? Since based on our previous calculation, hindi acceptable yung voltage drop, let's try yung 22 mm squared. Ito kasi yung kasunod ng 14 eh. From 14 mm squared dun sa proposed kanina, sunod natin 22. If hindi pa rin, let's go for the 30 mm squared. Pag hindi pa rin, let's use 38. Parang trial and error lang din eh. Okay? So, next. Same formula gamitin natin. Okay, so let's calculate ulit. 1.732 multiplied by 300 divided by 3.28 all over 305 multiplied by 54.86 multiplied by the impedance square root of 0.31 squared plus 0.048 squared. So, lumalabas ay 8.93 volts. Divide natin by 230. Lalabas ay 3.88% which is hindi pa rin acceptable kasi 3% ang target natin eh. So, let's compute for the cable na 30 mm squared naman. Same formula, Then the R and X will be, we need to obtain it from the table na kanina binabanggit ko. Okay, so ito na yan. 1.732 multiplied by 300 divided by 3.28 all over 305 multiplied by 54.86 multiplied by square root of 0.19 squared plus 0.045 squared. And that will result to 5.56 volts. Divide natin by 230 times 100 para makuha natin yung voltage drop niya. Okay, so it follows that percent voltage is equal to 2.41%. Technically, pasok na siya doon sa requirement natin na 3%. Therefore, we can use now that 30 mm squared or number 2 AWG. Yan yung i-recommend natin na pwedeng gamitin based on our calculation. Okay? Next problem. Let's use ulit yung PEC natin approach. A 15 horsepower 3-phase, ito for 40 volts naman, will be installed 55 meters away from the distribution panel. So, mangyayari dito is branch na siya. Verify the proposed number 8 o meron siyang proposed, so 8 mm squared ang proposal. Inside the metallic conduit is correct. Consider the voltage drop to be 3% or less. Gawa natin ng diagram. We have the motor control protection device. Ito yung cables natin. 55 meters. Okay. Let's try to calculate now. Using the PEC base formula pa rin kanina, assuming tayo ulit 85% yung power factor and then 80% yung efficiency. 15 multiplied by 746 divided by 1.73 2 times 440 multiplied by 0.85 multiplied by 0.8. Ang lalabas ay 21.62. Tama ba? 15 times 746 divided by 1.73 times 440 times 0.85 multiplied by 0.8. Okay, so 21.62 ang full load. Multiply natin siya sa, katulad ng kanina, multiply pa rin natin siya sa 1.25. The result is 27.02. And then using the table 3.10.2.6 B16, table of conductors and capacities, pwede natin gamitin yung number 10 or 5.5 mm squared at 90 degrees Celsius. Okay, so we will use 27.02 as our basis for the voltage drop. Okay, based on the value of R and X, we will use 0.063 and 1.2. Using the formula, 1.732 multiplied by 55 divided by 305. Pwede natin siya i-direkta kasi meters naman yung value nung given natin. Multiply by 27.02 multiply by the square root of 1.2 squared plus 0.063 squared. The resulting value is 10.14. 10.14 divide natin sa 440, that will result to 2.3%. Technically, pasok na pasok siya doon sa requirement ni Philippine Electrical Code. So, ibig sabihin, doon sa proposed nila na number 8, malaki na yung kable na yon. Pwede na nating i-recommend na gamitin yung 5.5 versus doon sa 8.0 mm squared. Number 1 kasi yung reason, pwedeng mas makatipid yung ating kliyente when using etong conductor na to compared to dun sa 8.0. Since may basis naman tayo, pwede natin palitan yung kable na propose nila. Okay? Next. Punta naman tayo sa calculation ng voltage drop using NEC. Yung approach ng NEC natin. Ito yung formula for a single phase system and then for the three-phase system. Mapapansin nyo na ang value ng nito for single phase is 2 and then for the three-phase is 1.73. Same din naman dun sa value natin ng Philippine Electrical Code. Dito lang, iba lang yung value ng K niya. Meron pa ring distance, meron pa ring current, and then nadagdagan ng circular mills. Ano nga ba yung circular mills? Ito yung unit ng area ng conductor. Merong mm squared, AWG, ito circular mills naman. Based dun sa formula natin, BD stands for voltage drop, and then yung K value is 12.9 for copper, and then K is equal to 21.20 when it comes to aluminum. Yung D nila is in feet, and then the circular mills, ang magiging reference natin dito is yung NEC Chapter 9, Table 8. And then I, same load current in amperes. So, ito yung makikita nyo sa screen natin, yung kanyang conductor properties, Table 8. So, ito makikita nyo, nandito yung size, wire size. Ito yung AWG. And then, ito yung area. So makikita nyo, ito yung mm squared, value ng mm squared yung ginagamit natin dito sa Pilipinas, at saka yung value ng circular mills. Ito po yun. Okay. Next. Let's try to solve. Ito yung problem kanina nung ginamit na yung Philippine Electrical Code. Kanina, nung ginagamit natin, nung sinolve natin, ang napalabas natin na kable doon is 30 mm squared. Tingnan natin dito kung parehas sila ng lalabas using the NEC approach. Same problem, same given, same method. Kinuha natin yung current draw ng any motor using the conventional calculation pa rin. Ito yung isa sa mga tables na dapat nating makita. Article 310, conductor capacities. Or conductor for general wiring. Diyan magbe-base yung size ng wire natin. Based dun sa makukuha natin na current. Okay? Using the formula kanina, BD is equal to 1.73 multiplied by the K value multiplied by the distance in feet multiplied by the current all over the area or the circular mills. For the sake of the discussion, we will use the power factor and efficiency to be 80%. Katulad nung kanina rin natin. Ito na yung lumabas, 54.86, same value. And then, based on table 3.10, number 14 pa rin yung nare-recommend niya. Pero since we will be applying yung voltage drop, let's see kung papasok pa rin siya. To obtain the value of circular mills, we will use chapter 9, table 8 of the NEC. In this problem, yung number 6 or 14 mm squared, ang value niya is 26,240 circular mil. Tulad kanina. And then, substituting ba the values, direct substitution na lang po tayo. VD is equal to 1.732 multiplied by 12.9 multiplied by 54.86 multiplied by the 300. And then, divide by 26,240. So, lumalabas 14.01 ang ating calculated voltage drop. So, kanina parehas din naman doon sa Philippine Electrical Code nung kinumpute natin yung 14 mm squared. Same scenario, umabot pa rin ng 6.1%. Technically, hindi siya ina-accept ng ating code dahil masyadong mataas. Remember, ang sinasabi ng code, even National Electrical Code or Philippine Electrical Code, dapat ang combination ng voltage drop ng feeder at ng branch circuit is less than 5%. Technically, pag pinag-aralan nating mabuti, from the feeder going to the distribution panel, dapat at least minimum of 2 2 to 3% lang. Ganon din sa branch. 2 to 3% lang para mag-sum up sila. Na ang magiging total nila is 5%. Or else, kapag lumagpas, bago tayo ng size ng wire, since ganon din ang scenario, dito, ibang calculation naman gagawin natin. Since we are using the NEC approach, we can derive the value for us to get the area. Sabi ko nga kanina, CM stands for the circular mills, which is ito yung area ng kable. Since we already have the BD, we assume 3% of 230 volts is 6.9 volts. Then, we will derive the formula for us to calculate the necessary or the required area of the conductor. Same values. Okay, so when it comes to calculation, now we can compute this one. 1.732 multiplied by 12.9 times 300 times 54.86 resulting to divide by 6.9 which results to 53,292.43. Ngayon, tingnan natin yung ating reference, yung sa NEC. Ito yung AWG number niya. Ito yung size ng conductor. Kung ilang mm squared. And then, ito yung circular mills. Basically, since 53,292.43, dito siya maglalaro sa number 3. Kaya ng 52,620, so maliit. Punta tayo dito sa 66,360 which is pasok naman siya and we will be using number 2 cable. All in all, if we will check, the result will be we can use number 2 AWG or 30 mm squared cable. Parehas tayo ng solution or parehas tayo ng result dun sa Philippine Electrical Code approach. Okay. Next. Okay, this one is the last problem. For problem number 2, using NEC formula. Same problem, a 15 horsepower 3-phase 440 volts motor will be installed 55 meters away from the distribution panel. So, verify pa rin natin kung okay yung number 8. Kanina, if we will recall the result, lumabas dun sa ating calculation na 5.5 mm squared is enough na when after we calculate the voltage drop. Yung number 8 niya rito, medyo malaki na yan. Pero tingnan natin dito sa NEC approach kung parehas ba na magiging result. Using the NEC base formula, 1.73 multiplied by the K, multiplied by the distance and the current, all over the area of the cable or circular mill. So we have the solution. Same approach. Dito nadagdag lang yung value ng CM. We will use chapter 9 table 8 of the NEC. This problem, number 10, AWG, which is equal to 5.5 mm squared, the value is 10,380 circular mil. So, direct substitution tayo ulit. 1.732 multiplied by 12.9 for the copper, multiplied by 55 meters. Since we are using the NEC, 55 meters should be converted into feet. So, multiply natin by 3.28 feet, then multiply by 27.02, then all over divide mo sa 10,380. The result will be 10.49 volts. So, same din kanina, it follows that the percent voltage is equal to 2.38%. Technically, we can accept the 5.5 mm squared as the conductor for this problem. We can recommend din ito sa kliyente natin na, sir, pwede mo nang gamitin yung mas mababang kable, mas makakatipid pa siya. Okay? So, basically, if we will check the result of the Philippine Electrical Code approach and the National Electrical Code approach, halos parehas lamang po yung resulta. So, any method yung gamitin mo dito sa dalawang to, it will be the same. But I highly recommend na gamitin natin muna, since nandito tayo sa Pilipinas, yung Philippine Electrical Code approach. Okay? If you have any questions, suggestions, recommendation, pwede kayong mag-comment dun sa YouTube channel ko. Dean ENG, capital G, TV, para dun sa mga questions, recommendations, and suggestions nyo. Please like and subscribe na rin dun sa YouTube channel ko para updated kayo dun sa mga i-upload pa nating video tutorials. Maraming salamat and God bless po sa lahat.